as was said, I'm a professor at the University of Oklahoma. I've been involved with Reasons to Believe for a long time. Back when I was here at Stanford, well, I'll give you my first slide first. So there's the University of Oklahoma. As was said, I'm not originally from Oklahoma. I went to graduate school at UCLA and spent 10 years here in the Bay Area working at SLAC. Both my kids were born here, one at Stanford Hospital and one at Santa Clara Hospital. So in the state of Oklahoma, they have a saying, the state of Oklahoma is a sooner state, so the saying is sooner born and sooner bred, and when you die, you'll be sooner dead. I always say my kids weren't sooner born, but they were sooner bred, because they were California born. But I've also worked with Reasons to Believe since about 1993. And so I met back then with that basically a 3-person operation with Dr. Hugh Ross and a couple other people. But I've always resonated with the message of Reasons to Believe and the way they integrate science and faith. So the chapter in Norman, Oklahoma has been going about 3 or 4 years. It's much smaller than this group here. We usually have about 20 people. But it's great to be here representing Reasons to Believe. And what I want to do is talk about this subject, scientific evidence for God and proposed naturalistic alternatives. If you've been around Reasons to Believe, then you've heard about the scientific evidence for God. So that's what I talked about this afternoon. I'm really going to try to run through that quickly. So I'll run through that quickly enough that you probably won't get all your questions answered. But I really want to look at the proposed naturalistic alternatives because that's one thing that people don't talk about a lot. Even at Reasons to Believe, somewhat. But let me first tell you a little bit about my research. I'm an experimental particle physicist, so here's the stuff that will be on the test at the end of the semester. So we know that the universe is made of atoms. Atoms have a nucleus at their core. Nuclei are made of neutrons and protons. Neutrons and protons at the very fundamental level are made of quarks. I spent most of my career studying how quarks fit together within the proton. I'm now doing some other different kind of research, but in the same field. For the last 5 years or so, I've done my research at a place called CERN, or the Large Hadron Collider, which is a tunnel about 17 miles around, about 300 feet underground. And in that tunnel, we accelerate protons to nearly the speed of light and smash them together. Why do we smash them together? Because we want to know what protons are made of, what the universe is made of. The analogy I give is if you want to know what your car is made of and you don't have any tools to take your car apart, get it going really fast and smash it against a brick wall. Break it into smaller pieces. That's how we break the proton into smaller pieces. If you were to go inside a tunnel, you would see something like this. These big blue things are superconducting magnets to bend the protons. If you were to open up one of the blue things, you see these 2 tubes here and here, which are covered, but they would carry protons at nearly the speed of light in alternate directions. Everything is liquid helium cooled. The superconducting magnets are cooled to about 1.4 degrees Kelvin. The protons are moving 99.99999% of the speed of light or something. And every once in a while, we take those 2 beams with protons moving in opposite direction, and we bring them together at one place. So this little blue thing you see there is a drawing of the detector I work at. It's called the Altos detector, and it's really a big camera to see what the debris is when the protons collide. Another drawing of the detector is here to give you some idea of the size. These are people. Wow. So protons come in one direction in one pipe, and another direction in the other pipe. They collide in the middle, and they actually make more particles. That the energy of their kinetic energy, their energy of motion, is turned into mass energy. That's what E equals mc squared actually means. You can make mass from energy. So we take the energy of their motion and we make mass. Some of the statistics are there. It's about 8 stories high, about half the length of a football field, and about 3,500 people work on this. When the protons collide, they make a lot of new particles. Each of these little kind of lines that are curled as a particle that was created. And my job as an experimental particle physicist is to diagnose pictures like this and understand what happened when the particles collided to probe the structure of the universe. This was one of the 2 detectors that discovered this so-called Higgs boson, named after Peter Higgs. The picture is up here in 1963. He was one of 6 scientists who predicted that this particle should exist. And 50 years later, about when he finally discovered it, a Nobel Prize was given to Peter Pates and Francois Englert, not because they discovered it, but because 50 years before they predicted it should be there. It's quite remarkable to me. This particle is sometimes called the God particle. There's the book. And that's the only reason it's called the God particle, is because Leon Letterman wrote about it, and he wanted to sell books, and nobody would buy a book if it was called The Search for the Higgs Boson. So he named his book The God Particle. And it was a good marketing ploy. It sold a lot of books. There's not a single physicist who calls it the God particle. We call it the Higgs boson. So when I give talks a lot, I talk about modern scientific evidence for God. And I talk about 3 things: the origin of the universe, design in the universe, and the rare earth. This is what I really want to run through fast. So if you haven't seen this before, I will go through it too fast. If you have seen it before, I'll still go through it too fast. But what I really want to get to is this thing. For nearly 50 years, theists, Christians have claimed that these 3 things point to God. And so in the last 10 years or so, there's been a plethora of response to that claim. And I want to I've read a lot of the response, and I want to give some thoughts on my response to the non-theistic proposals. But to do that, I have to give you a brief overview of these 3 things. So that's what we'll spend the first part of the talk talking about. So the origin of the universe. We now know the universe began in what we call the Big Bang. There are 3 pieces of evidence that have convinced scientists of that. The first is that the universe is expanding. The universe is getting bigger. You can run the film backwards. It must have started to expand at one time. And that starting to expand is the beginning of the universe, the Big Bang. Not only that, but our theory of the Big Bang predicts exactly how much hydrogen and helium and other light elements should be in the universe. So our calculations, when the universe was first formed in the first 3 minutes, the only elements formed were hydrogen, helium, and a little lithium and stuff like that. But nothing that we're really familiar with, like carbon and oxygen and nitrogen and silicon. That was all formed much later. And our theoretical calculations predict how much of this stuff we should see almost exactly, to like 1 part in 10,000. And so that's a firm evidence that the universe started as Big Bang. And then finally, the temperature of the universe, which we call the cosmic microwave background radiation. This is probably the most compelling evidence for the Big Bang. The universe started out really hot and very dense. You take the whole universe and combine and compress all of its energy to the size of, I don't know, something smaller than a cantaloupe. You know it's going to have a lot of energy in a small region. And that's what we started with. And although it's been expanding and cooling since then, we should still see that residual heat. We call it the cosmic microwave background radiation. This is a picture of what that looks like, a picture of the whole sky. The different colors are slight variations in the temperature of the universe. The different colors represent variations of 1 part in 100,000. So extremely minor differences, but again, exactly what we predict. And so these 3 pieces of evidence are the observational evidence that the universe had a beginning. But there's not only observational evidence, there's theoretical evidence. In 1915, Einstein wrote or developed his theory of general relativity. The theory of general relativity predicts that the universe should be expanding. Einstein didn't like that. He actually threw in a fudge factor, something called a cosmological constant, to try to avoid the fact that the universe was expanding. When Hubble made the discovery in 1929 that the universe was expanding, Einstein said that that cosmological constant was the biggest mistake of his professional life, because he should have predicted the universe was expanding. In 1973, Hawking, Penrose, and Ellis took Einstein's theory of relativity and expanded it to include time. And their conclusion was that the universe had a beginning of space and time and matter and energy. And so the Big Bang is kind of a misnomer. Big Bang sounds like something is there to explode, like a bang. But it's really not a bang. It's a beginning of the universe. And then in 2003, Bourdais, Guth, and Vilenkin, 3 theoretical physicists, developed a more impressive theory even, because it's so general. And their theory says basically, their confirmed theory says basically that any universe that on average is expanding must have had a beginning. And so both the calculations from these theoretical physicists and the observations point to the same thing. And this is the conclusion, that the Big Bang was the origin of everything we know in the universe. It's the origin of the universe. It's not an explosion of something that pre-existed. It's the beginning of space-time, matter, and energy. Now, the problem is if the universe had an origin, if everything had a beginning, then whatever caused this universe can't be a part of the universe. It has to be outside the universe. And that points to God. It's not my idea that it points to God. It's every physicist who thinks about that will agree, even those who don't believe in God, will agree that this could point to a God. Robert Jastrow wrote this famous quote you may have seen before. As the evidence for the Big Bang became overwhelming, he wrote, "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the rock, he's greeted by a band of theologians who have been sitting there for centuries." So this is a common idea, that the origin of the universe points to a transcendent cause that looks a lot like God. The design of the universe. The design of the universe is sometimes discussed as the anthropic principle, anthropos from the Greek word that means humanity. And the idea is that many of the parameters of the universe seem to be precisely tuned to allow humans to exist. The analogy I give is if you had a panel of 100 knobs, and you take any one of those knobs and twist it just one way or another, just a little bit, you either have no universe at all, or a universe that's inhospitable to life. The definitive book on this is by Frank Tipler and John Barrow, called The Anthropic Cosmological Principle. It's a good book on this subject. It's full of very challenging mathematics, so I don't recommend it unless you like challenging mathematics. But they propose that the universe seems to be designed. I can't list 100 different things, so to give you some idea, I'll just show you 2 examples. One is the strength of the strong nuclear force. So this is a review for the quiz. You know, everything's made of atoms. Atoms are made of nuclei. Nuclei are made of neutrons and protons. Neutrons and protons are made of quarks. And ultimately, it's the strong nuclear force that binds the quarks together and ultimately holds the nucleus together. So if you want to know why the nucleus is held together, you study the strong nuclear force, or why neutrons and protons exist. So this is what I spent 30 years of my life basically studying. It's because of the exact strength of the strong nuclear force that we have the famous periodic table. If you were to take the strong nuclear force and make it 2% stronger, you would basically eliminate hydrogen from the table. So if I take that knob that represents the strong nuclear force and tune it 2% up, I get rid of hydrogen. Well, that's a problem for life, right? Water is H2O. The H is hydrogen. The sun burns hydrogen. So if you make a strong nuclear force 2% stronger, you don't have any hydrogen. You don't have a universe that can support life. If you take that same knob and make it 5% weaker, then this is what the periodic table looks like. There's only hydrogen. Right? So chemistry class becomes really easy. Here's our periodic table. We're going to study hydrogen today, and hydrogen tomorrow, and hydrogen the next day. But it's not very good for life. So that's one of the many things that are fine-tuned for life. Another one is the amount of matter in the universe. The amount of matter in the universe, shortly after the Big Bang, about 10 minus 20 seconds after the Big Bang, was finely tuned to 1 part in 10 to the 60th. If you had changed the amount of matter by 1 part in 10 to the 60th at that time, you would not have our universe. Because if you have too little matter, then everything expands so fast that galaxies and stars can't form. If you have too much matter, because everything is attracted to everything else by gravity, it starts to expand, but it collapses before it has a chance to form galaxies and stars. So we think we know why this is true. So this is an important point. So how did we get this matter to be so well finely tuned? We used to think it was some kind of, I don't know, divine intervention. We now think we have a mechanism. We think the mechanism is something called cosmic inflation, which actually forces the matter to do exactly what it should. I gave a talk about like this at Stanford, and a physicist came to me and said, you can't use the amount of matter in the universe as an argument for fine-tuning. And I said, well, why not? He said, because we think we know how it happens. Cosmic inflation may force the matter to be what it should be. And I began thinking about that. So at home, in Oklahoma, I have to mow my grass every week in the summer. I mowed it for the first time last week. It's really terrible because it means I'm going to have to do that every week for the next few months. But I have this fine-tuning problem when I mow the lawn. That is, I want to pour gas into my lawnmower, but there's a little tiny hole to get the gas in. And it's really hard to get the gas in that little tiny hole. So what do? I take a funnel. And the funnel is finely tuned in that it forces the gas into the hole regardless of where I pour it. It's a really nice mechanism. Now the fact that I have a mechanism that does the job, does that eliminate the fine-tuning problem? Or does it just move it up one step? Who created the finely tuned mechanism to get the job done? And so just because we think we have a mechanism that provides that forces the matter to be exactly what it should be, does that really solve the fine-tuning problem? My answer is no. An efficiently tuned mechanism requires an explanation and still exhibits design. And we may come back to that. At least we will talk about that a little bit tomorrow night, actually. I don't know, we may bring it up in questions. But the point is that even if you know how nature does something, how nature gives you the right amount of matter, if that mechanism is finely tuned, then it still points to a designer. So this is one of 100 or two of 100 finely tuned parameters. There's a whole bunch more that scientists have seen and understand. And then last I want to talk about the rare earth. I'm not going to spend much time on this. It says, what's required in order to have a planet that's capable of supporting higher life forms? Dr. Hugh Ross, if you've read any of this stuff, really discusses this extremely well in some of his books. In fact, what was the latest book that just came out? On this very subject.
Improbable Planet.
Improbable Planet. I should know that because I wrote an endorsement for it. So anyway, he does a much better job than me. But in order to have a planet that can support anything more complex than bacteria, there's actually some very strict criteria. One is you have to be in a spiral galaxy, like the Milky Way. And you can't be anywhere in the spiral galaxy. You have to be from about 1/3 of the way out to 2/3 of the way out, which is called the galactic habitable zone. And of course, the sun is right there. You have to have the right kind of star. Our sun is a class G star. It's the only kind of star that burns stably enough and long enough to support planets like the Earth. You have to have a planet that's the right mass, that has the right rotation rate, that has tectonic activity, that has the right axial tilt, that has the right amount of water. There's so many parameters about the Earth that make it suitable for higher life forms. You have to have most likely a single large moon, and maybe even an extremely large planet like Jupiter to have such a large gravitational field it shields the Earth from comets and asteroids that might hit it. So again, I'm not going to any detail. There's plenty of details in books like The Improbable Planet. There's plenty of details in this book. This book was written some years ago now by two non-religious scientists called Rare Earth, and they write some godlike being to be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that power would face a formidable task. It is unlikely that Earth could ever be truly duplicated. And that's the take-home message, that the subtitle of Rare Earth is why complex life is uncommon in the universe. So physicists have seen these kinds of things. They write statements like this: a common sense interpretation of facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. And then Alan Sanders writes, I find it quite improbable that such order came out of chaos. There has to be some organizing principle. God to me is a mystery, but it's the explanation for the miracle of existence, why there's something instead of nothing. So basically, here's the summary of the first part of the talk, which You know, again, if you've been around reasons to believe, you've heard a lot before. If you haven't, then, you know, I went way too fast. But first, the Big Bang origin of the universe, which was started to be developed in the 1930s, we're still learning about it, says that the universe has a transcendent origin. The anthropic principle developed in the 1960s, we're still learning about it, says the universe appears designed for humans. And finally, the rare Earth hypothesis says that the habitable Earth seems rare, if not unique. So theists have been declaring these three things since they've been developed throughout the last 50 years or so. And the evidence for these ideas keeps getting stronger. When I started giving talks like this 20 years ago, there was not as much evidence for each. These three principles were there, but there wasn't much evidence for them. The role of the moon and how important a single large moon is in the Earth's habitability has really developed over the last 10 or 15 years or so. Certain aspects of the anthropic principle, like the formation of carbon and dying stars, has developed new ideas over the last few years that have really strengthened that. So the evidence for this keeps growing stronger. And in response, there have been just a multitude of books that have been written that try to refute some of these ideas. To avoid the need for a beginning of the universe or deity or some challenge to fine-tuning. So here's three of them: A Brief History of Time by Stephen Hawking, The Universe from Nothing by Larry Krauss, and The Fallacy of Fine-Tuning by Victor Stenger. I try to read books on all sides of these ideas, because the only way I can find out truth is to read what people write on both sides. So these are all books I've read, and so I want to talk about them. But first I want to talk about the grand designs. This was a book that came out in 2010 by Hawking and Mlodinow, and it was an interesting book. When I first read it, the first chapter caught my eye, because three questions are posed by Hawking in the very first chapter. And at this point, I kind of thought that those three arguments for God that I'd given were old and maybe even tired by 2010. And then I read the first chapter, and Stephen Hawking asked three questions. Why is there something rather than nothing? Why do we exist? And why this particular set of laws and not some other? And it became immediately clear to me that these are exactly the three things I've been talking about. Why is there something rather than nothing? That's the origin of the universe. Why do we exist? At least in part because of the planet we live on. And why this particular set of laws and not some other, the anthropic principle. And it occurred to me, 8 years ago, why is Stephen Hawking writing this book? Because theists have been talking about these three things for so long that he wanted to make a rebuttal to them. And rather than these three arguments being old and tired, since they've been developed in the 30s, the 60s, and the 2000s, they are compelling. Because in 2010, there's still a need to try to refute them. So I write, the fact that the authors felt compelled to write a book addressing these issues shows that the evidence for God for scientific discovery is relevant, prevalent, and compelling. So this is one of the many books. So I want to go through these three things. The origin, the rare earth, anthropic principle, and discuss the latest ideas that are opposed to them. So first of all, there's really just one response to the rare earth. And this is the response. There are lots of planets out there, so one must be suitable for life. And at first that sounds like a plausible explanation. We found over 3,000 planets, and there's probably at least 100 billion trillion planets or something like that. There's a lot in our visible universe. But then you have to ask the question, should we expect to find a planet like the Earth among them? And what's an Earth-like planet? What conditions are necessary for an Earth-like planet to exist? If you read science news in the newspapers, you will often read the scientists have discovered another Earth-like planet. You read it all the time. Let me tell you right off the bat, it doesn't mean an Earth-like planet. When scientists say they found an Earth-like planet, they mean one of three things. They mean either the planet is in the right orbit around its sun to possibly have liquid water on it. Well, our moon is in the right orbit around the sun to possibly have liquid water on it. It's not an Earth-like planet. Or they mean that the planet is about the same size as the Earth. Well, Venus is about the same size as the Earth, and it's not an Earth-like planet. Or they mean that the planet is rocky and not gaseous. Well, Mercury is rocky, and it's not an Earth-like planet. So when you read they found an Earth-like planet, they haven't. What they mean is one of those three things. So what does it take to find an Earth-like planet? Well, we kind of went through some of the stuff really quickly. It's got to be in the right galaxy. That's about a 10% probability. The star has to be the right distance from the galactic center. That's a 20% probability. And you can go through the list. This is just a partial list. A complete list was compiled by Dr. Hugh Ross at Reasons to Believe. And there's 322 parameters. This is an old complete list with 322 parameters. He's come up with a new one as he continues to read the literature that has more. But if we just take these 322 parameters and do the math, including what are called correlations, there's a 1 in 10 to the 304th chance of finding an Earth-like planet. There's a lot of planets in the universe, but there's still a really small probability of finding an Earth-like planet. In physics, we have a number. We have a word for a number that's small. The word is it ain't going to happen. Right? So, I mean, this is literally Stephen Hawking's response to the rare earth. In one flippant sentence, he says, there's a lot of planets, so one must be like the Earth. But if you just do a back-of-the-envelope calculation, you find that's false. So the claim is, since there are many planets in the middle of the universe, there must also be many that can support higher life forms, is an unsophisticated claim. It does not seem to consider the actual conditions necessary for higher life forms to exist. So I don't know, if there is a God who made one planet like the Earth, he might have made a lot. But we can't just say that because there are a lot, there must be one like the Earth. That's the easiest one of the three claims to dismiss. So what about the response to design and fine-tuning? So a major response to fine-tuning is that there's a multiverse. There's an infinite number of universes, and we happen to live in one that can support life. Now there are lots of different ways this could happen, and I can't discuss every single possibility. I can't refute every single possibility either, because there's no evidence for any multiverse. There's no evidence. So if you believe this, it might be true, but at this point, a belief is purely based on blind faith. It's not scientific. One of the examples is something called M theory, or string theory. It proposes there are at least 10 to the 500 different types of universes. But string theory, like the rest of these options, is not really a theory. Stephen Hawking appeals to M theory in his book, The Grand Design, and in the review of that book, John Horgan writes this, which I like. M theory, theorists now realize, come in almost an infinite number of versions, which predict an almost infinite number of possible universes. Of course, a theory that predicts everything really doesn't predict anything. And this is one of the problems with string theory, or with any theory of multiverses. We do not know what the theory is. It's a proposal without any mathematics behind it, without any real firm predictions behind it. So it predicts anything. And if you want to predict anything, you can, but it's not science. Real science is based on experimental results, not on speculation. So an appeal to the multiverse to solve fine-tuning problems is not based on science. And it creates what we would say are ludicrous scenarios, right? What's the most probable universe if there's an infinite number? Well, the most probable is something called a Boltzmann brain. That none of us are real, we're just a figment of somebody's brain that popped into existence for a brief period of time and went away. Because it's easier to pop a brain into existence than to pop a universe into existence. So it's more likely that we're just a bunch of brains somewhere. Or, if there's an infinite number of universes, then every possibility has occurred everywhere. So there's another lecture going on in another universe where I'm speaking to an audience just like you, but one of you is missing. Okay, I don't know why, but you are. Okay, and so the multiverse can lead to seriously ludicrous conclusions. Could those be true? Yes, but they're not things people would really take seriously. But they're serious implications of a multiverse. So there's no observational evidence for a multiverse. There may never be. But suppose we did find one. Would that threaten the idea that the universe is fine-tuned? Well, I don't know the answer. We can only solve that if we know what the universe would look like as a multiverse. So how does that affect the evidence? These are just a few random thoughts. First of all, we only know how it would affect fine-tuning if we actually discovered a multiverse and could do the mathematics. But I'll tell you this. So far, everything we've discovered points to God. the size of the universe, the laws of the universe. I would make a prediction that if we ever find a multiverse, I know the direction of the slope. It gives better evidence for God with every new discovery. And so I don't think even if we find it, it will threaten it, but we don't know that until we actually find one and develop a mathematical theory so that we know what it predicts. But even if there was a multiverse, then we live in an improbable one, because most of them would not be suitable for life. And so we still have to ask ourselves, why do we live in an improbable universe? There's the famous example is if you stand in front of a firing squad with 100 sharpshooters, and they all shoot and they all miss. You can either just say, well, I happen to be in the right universe where all the sharpshooters miss. Or you might ask, I wonder if there's something more, really important going on, why they all miss. And so, why is it that we live in this improbable universe? It might be possible that the laws of physics actually require a multiverse. Suppose you're God and you say, I want to invent a universe. That universe is going to be based on string theory. String theory requires 10 to the 500 universes, even if I want to make one planet. So maybe I'll make 10 to the 500 universes. So again, I don't know. That's a possibility. So we might find out that if you want to make one planet suitable for life, the only way to do it, given the laws of physics, is to make a multiverse. That's certainly a possibility. So the discovery of multiverse may actually strengthen the evidence for God rather than turn away from God. And then my final thought is just kind of a flippant but maybe a profound thought, is how many universes would an infinite God make? Right? So maybe making 10 to the 500 is a cool way to make a planet like the Earth. I don't know the answer. If you want more information on this, I recommend this book by Reasons to Believe astrophysicist Jeff Zeering. He's written a great book called Who's Afraid of the Multiverse. He goes into a lot more detail than I will go into. But the other answer to the fine-tuning problem is this one. Just Victor Stenger says there is no fine-tuning. He wrote a book called The Fallacy of Fine-Tuning, and in response to, physicists wrote a book called A Fortunate Universe, which actually refutes the fallacy of fine-tuning. I'll talk a little bit more about this book. This is Luke Barnes and Grant Lewis. They're both Australian astrophysicists. But Stenger's book is very interesting because he writes it in such a way that if you don't read it carefully, you think, oh, he's got a great argument against fine-tuning. But if you read it carefully, you will begin to understand that his arguments are fatally flawed. Let me give you one example. So this is actually from Luke Barnes, who wrote The Fortunate Universe. He caught this in Stenger's book, and then once I saw that, I saw these other kinds of flaws that Stenger makes. So this is what Stenger's argument is. If our formulation of the laws of nature is to be objective, it must be what he calls point of view invariant. In other words, the laws of physics should look the same no matter where I'm looking from. That makes sense. Invariance implies conserved quantity. This is something called Northrup's theorem, and this is a well-established fact of mathematics. Thus, when our models do not depend on a particular point or direction in space or a particular moment in time, that's point one, then those models must necessarily contain the quantities linear momentum, angular momentum, and energy, all of which are conserved. That's point two. And so the conservation principles are not laws built into the universe or handed down by deity to govern the behavior of matter. They are principles governing the behavior of physicists. So you read that, it sounds airtight. If point one, which is true, every physicist will agree with that. If point two, which every physicist agrees with, then point three follows. These are not fine-tuning laws. But here's the problem. The conclusion is based on a false premise. The word invariance in point two should not be invariance. The word physicists use is symmetry. Symmetry implies conserved quantities, not invariance. So what he's done is, in physics, symmetric and invariant have precisely distinct meanings. So by using the word point of view invariant in point one, and then inserting the word invariance instead of symmetry in point two, he makes this conclusion. But you can't do that. Because the correct word in point two is symmetry, not invariance. They're not the same, and then the conclusion doesn't follow. This is a fatally flawed argument, because he's changed a word that has a precise meaning to make the argument sound good. And if you read his book, you would never catch, I read the book and didn't catch, that he substituted the word invariance for symmetry. Very tricky. But then the argument looks foolproof, but not when you put the right word in there. Okay? It's very interesting. So I found this interesting. Stenger writes a popular book, The Fallacy of Fine-Tuning. Luke Barnes wrote a scholarly article that is really detailed. I mean, this, if you want to see every one of Stenger's points refuted, you read this article, Fine-Tuning the Universe for Intelligent Life by Luke Barnes. He's a postdoc, so a young guy, really bright. Physicist Victor Stenger wrote a popular book to try to refute fine-tuning, and cosmologist Luke Barnes wrote a technical scholarly article rebuttal, and the overwhelming consensus of those who read both publications, this is a quote, is that Barnes' case is far stronger than Stenger's. And then Barnes and Lewis wrote The Fortune of Lunar Universe. This is great, because Luke Barnes is a theist, he's a Christian. Grant Lewis is an atheist, a non-theist. And they wrote a book together, and they both agreed that the universe is definitely fine-tuned. Luke Barnes thinks it's because God, Grant Lewis thinks it's because there's a multiverse. But the idea that the universe is not finely tuned is just, which Victor Stenger argues for, is completely eliminated. This is what they write in the book. This reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field of fine-tuning began in physics journals and remains with the physicists. While there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. The universe is fine-tuned, and so Victor Stenger has been completely refuted. All right. So that's the argument about fine-tuning. What about the origin of the universe? So here's the bottom line. We really don't know the origin of the universe. Everything we know starts about 10 to the minus 35 seconds after the Big Bang. So, by the way, the Big Bang has two different meanings. Sometimes we refer to the Big Bang as the origin of the universe itself. Sometimes physicists refer to it as the moment we start to understand the evolution of the universe, which is about 10 to the minus 35 seconds after the universe began. So when you hear physicists say that the Big Bang origin of the universe is in question, they're not referring to 10 to the minus 35 seconds after the Big Bang until now. That's not in question. What they're referring to is what happened in the first 10 to the minus 35 seconds, which nobody knows. So there's room for speculation. But if you run the film back 14 billion years to 10 to the minus 35 seconds after it started, and it keeps getting smaller and smaller and smaller, like it had a beginning, you know, every one of you who's had a math class or a physics lab has done extrapolation curves. You don't have to extrapolate very far to get to an actual beginning. Nevertheless, there are proposals that try to get rid of the beginning. And this is the two proposals. Either there was no actual beginning of our universe, or the beginning of the universe was a purely natural event, thinking that if it's a natural event, then it takes God out of the picture, which it doesn't do, but we'll talk about that. So we'll talk about those two proposals. So before we do that, let's give the scientific review. At about 10 to the minus 32 seconds after the Big Bang, the visible universe was very hot and dense, and it's expanded and cooled since then. Nobody refutes that. All known theoretical calculations indicate the universe had an actual beginning. The Bordet-Lincoln theorem has no loopholes in known physics and applies even to a multiverse. So even if you have a multiverse, the universe had to have a beginning. And the thing I haven't even discussed yet is what's called the entropy problem of the universe. Entropy is very loosely defined as the amount of order or disorder. And the universe, the Big Bang, was a highly ordered event. It was not a chaotic explosion. It's a beginning of an ordered universe. Roger Penrose has calculated this beginning of the universe, the order, as being fine-tuned to 1 part in 10 to the 10th to the 123rd power. Okay? There's only 10 to the 80th particles in the visible universe. So if you were to, pick one out of every one particle in the universe, mark it 1 with an X and picked it out, it's still a better probability than this number here. And almost every non-theistic model has no explanation for this entropy of the universe. In fact, Michael Shermer, who is I think it's Shermer. I'll have to look this up. Sorry, don't record me on this. Who was it? There's a physicist who just, I was just reading, it's not Sherman, no, I can't remember who it was, Sherman. But anyway, it'll come to me. And he was basically saying this is almost an intractable problem, is the entropy. His one idea did come up with some solution to the entropy problem, but almost every model of the universe in the beginning has this problem. So here's what we know given the scientific observations. Everything that's scientifically observable, measurable, is supporting evidence for a transcendent cause. So the non-theist has to appeal to gaps in our knowledge to make a case for no deity. So where Christians are sometimes accused of appealing to the God of the gaps, that is, if we don't understand it, we say God must have done it. Everything we do see is consistent with God. So what the atheist has to do is to make up new laws of physics in arenas where we don't know the laws of physics that would somehow take God out of the picture. The tables have completely turned. It's now an atheism of gaps. So the atheist has to invent laws of physics in the first 10 to the minus 35 seconds, because we don't know what happened there, that would take God out of the picture. And these proposals are speculative. They require unknown physics to actually supersede what we do know. They almost all contradict the VGB theorem, and very few solve the entropy problem. So if you read Larry Krauss about the VGB theorem, Lincoln is very strong in saying that this means that the universe has a beginning. But then he'll make one caveat, unless, of course, there are laws of physics we don't know about. So Larry Krauss will grab onto that and say, the VGB theorem doesn't say that the universe had a beginning, because there might be laws of physics we don't know about. Right? Well, you can take that for what it's worth, right? So here's the first idea. There was no actual beginning to the universe. It violates all known physics. Even oscillating universes and multiple universes require a beginning. All right. So two examples of this. All are these gap proposals, atheism of the gaps. Stephen Hawking's no boundary condition would still require a beginning. This is a great one. You may have heard of Ali's and Goss's paper that was published. It made national news about a year ago, and it says that the Big Bang never occurred. There's no actual beginning. So this is a little bit technical. They use what are called Bohmian quantum trajectories. So if the universe had a beginning, you can think of all the space that's expanding comes back to one point, called singularity. So everything has to come back to one point. It's like lines that eventually cross. Well, by definition, Bohmian quantum trajectories cannot cross. So they start with a theory that says these lines can't all come together, and their conclusion is the lines can't all come together. And they say we disprove the Big Bang because we started with an assumption that it can't happen, and therefore it can't happen. And this made the headlines were, the Big Bang didn't happen because these guys used a certain kind of reasoning that we're not allowed to. So here's what Lincoln says: with the proof now in place, the proof, and he's the guy that wrote the theorem, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. The other alternative is that the beginning was just a natural event. And there's lots of ideas that the universe was stagnant through most of its history. This is one in a series of universes, or the most probable, or the most, the one that physicists like the most of the universe is a kind of quantum fluctuation. I'm kind of running short on time. If the universe is stagnant, you can read it. It still requires infinite fine-tuning in the past. It can't be stable. This really is not a viable idea because the universe can't be stable, so it can't exist forever before it starts to expand. But some people hold on to this. The universe is one in a series of universes. It's possible, but then you still don't solve the entropy problem. And the VGB theorem still says that one of those universes in the not too distant past had a beginning. They still have the beginning problem. But the most prevalent idea is that the universe is some kind of quantum fluctuation. This is what Larry Krauss proposes in the universe from nothing. The problem is that quantum fluctuations, which are really weird events, they're particles popping into existence from nothing. But they don't really come from nothing. They come from the space-time fabric of our universe. You don't have particles popping into existence from nothing What you have is that space and time itself are not nothing. They are something. And from that something of space and time, particles can pop into existence. So what Strauss wants to do is appeal to some kind of analogous fluctuation as the cause of our universe. Again, this is the atheism of the gaps. But the problem is such a fluctuation, if it's truly analogous, is not from nothing. It's from something like our space-time universe. It's from something that already existed, that's pre-existing, that's not a part of our universe. And one author said that sounds a lot like God. Right? There's something out there that's not a part of this universe that has the ability of popping universes into existence. And that's what Larry Krauss is proposing. So again, none of these ideas have any evidence, either observation or theoretical. They all require some laws of physics to exist. And this is important. They not only require some laws of physics to exist, but they require those laws of physics to work. I can write mathematics down, and that doesn't build a building. It just describes how the building will be built. It takes someone who has the power and capability to actually create the building. So even if I write the laws of physics down, in Stephen Hawking's words, who brings those laws of physics alive? Who gives them fire? Okay? And Blinken writes this: the description of the creation of the universe from nothing is given in terms of the laws of physics. That makes you wonder, where are these laws? If the laws describe the creation of the universe, that suggests they existed prior to the universe. The question that nobody has any idea how to address is where these laws come from and why these laws in particular. And then finally, this is a real important thing. Even if there's a natural origin of the universe, even if we were to discover that this universe is a quantum fluctuation, it would still be in agreement with the theistic viewpoint, with the biblical record. What the Bible says is, in the beginning, God created the heavens and the earth. That's a description of what God did to create this universe. It does not tell us how he did it. If God wants to use a natural process to create the universe, it's still God creating the universe. Let me give you an example. God used a natural process to create every one of you. Yet, if you're a believer in God, you believe that he was intimately involved in that. So God uses natural processes all the time that he's still intimately involved in. What the Bible tells us is that he created this universe. It doesn't tell us how. And so even if we were to find one of these natural processes that caused the universe, the biblical description that in the beginning God created the universe has already been confirmed, regardless of how that came about. That description has been confirmed by the Big Bang Theory that has been confirmed. So all evidence supports a divine designer. If you told me 100 years ago that we would now know that, let's put all this up. If you told me 100 years ago that we would now know that the universe appears to have a beginning, that it looks like the laws of physics were designed, nobody would have agreed. Nobody would have believed it. That the physics and the astronomy were just not developed enough. And if I was to write the script over the last 100 years, the best script I could write to get evidence for the God of the Bible, it would look exactly what has happened over the last 100 years. You would find evidence for an origin of the universe, and you would find more and more evidence for design of the universe, which we keep finding, and you would find more and more evidence that the Earth is a unique planet. And this is exactly what we found. So the bottom line here is the proposal that a transcendent intelligent being created and designed this universe is arguably the best evidence, or the best explanation given the evidence. So that's the end of my talk. We'll break for 15 minutes of questions. I do write a blog. I started about a year ago. I don't have a lot of time, but a couple times a month I'll put something there. So if these kinds of questions interest you, you can go there. So 15-minute break, and we'll have some questions.
Great. Thank you.
This is not a false story. It's totally true. I had one publisher that told me I should self-publish it, so that's what I'm going to do. So it'll be coming out this summer. It'll be called The Creator Revealed. And I hope that it's something that is easy to understand, and it looks at both the Big Bang and the Bible. So that's another resource. If you are interested in how some of the things I talked about tonight actually fit into the biblical record, I'm going to be talking at Neighborhood Bible Church in San Jose tomorrow night from 6 to 8:30, 1302 Branham Lane in San Jose. And there I'll be talking about Christianity and science, whether there's a conflict or agreement, and I'll talk a little bit at least, about how the things I've talked about tonight fit into the biblical record. And so if that's something you're interested in tomorrow night, you're welcome to come. All right, so let's open it up for any questions. Yes? Go ahead. Okay.
Let me focus on the infinity, which is the multiverse, which is getting rid of God by exchanging an infinite number of universes instead, where something has to work out. You know by the history of physics that has to be wrong. Infinities always tell you that you have no idea what you're talking about. Whether it's the ultraviolet catastrophe or whether it's quantum electrodynamics, infinities tell you you have no idea what you're talking about. In that sense, it really is perfect fodder for a believer, because these things can be refuted even without physics, I think. You can refute it metaphysically. It's silly. And one of the ways, for example, it's good to mock atheists the way they mock Christians. If you're in New York, or you like to do that kind of thing. What I mean is, do you agree that an infinite number of universes is like a silver platter for us? Because if you could show up in a universe with a black shirt, or whatever your example was, then there's a universe where there is a God. One of these infinite universes, there is a God. And being all powerful, he's going to take over all of the universes. It doesn't, it's really bad for them. Because it shows how infinities are absurd. Metaphysically. Do you agree?
Most of the multiverses are not necessarily a true infinity. But I agree with you. There are possible theoretical reasons to postulate a multiverse, but again, every previous experiment has given every previous observation has given further evidence for God. No metaphysical problem for the true infinite number of universes. I love your example that in one of them there's a God and he'd take over all of them. Let's wait and see. Yeah. Do you have a question?
Yes. Buzz Aldrin and some of the astronauts claimed they were out in space, they saw UFOs. Buzz Aldrin said there's a little L-shaped thing that flew close to this capsule and flew away. You can Google this. They said it. Are they putting us on? Are they having fun with us?
So there's a book that Hugh Ross wrote, The Present Reason to Believe, called what? Lights in the Sky and Little Green Men or something.
With Jeff Waring, yeah. Mm-hmm.
UFOs. So he's more of an expert than me. I will refer you to that book.
Okay.
Most of the supposed sightings of UFOs have been easily explained. Okay. There may be some that haven't been. The speed of light seems to be an absolute speed limit of the universe. And if we are limited to the speed of light, interstellar travel becomes very challenging. Okay. So I don't know who's putting who on. I do know from reading the internet that there's somebody who believes anything.
There's a morning radio that Buzz Aldrin saw something fly to the
Yeah, well, there have certainly been things that have been seen that are not necessarily explained by what people know, but there's also people who, I don't know. I don't think that physical aliens from other parts of the universe could have visited us because of the distances required and the limited speed. But that's my personal opinion. There's more to the universe than I know.
All right.
Yeah. Anything else? Yes, sir. Yeah.
Could you give a brief critique on Stephen Hawking's statement that starts out, because there is such a law as gravity, or such a thing as the law of gravity, the universe can and will create itself from nothing?
Yeah, well, again, this goes back, there's two issues with that. Where did the law of gravity come from? Who created that? And a law of gravity is descriptive. It doesn't have power to create. Right? The law of gravity describes how gravity works. It's like me writing the description of the forces necessary to hold up this building. That description does nothing to create the building itself. I mean, most physicists I know would laugh at that statement. Occasionally you will get a Stephen Hawking or a Richard Dawkins or a Larry Krauss writing a philosophical statement that's far outside their expertise, right? The laws themselves don't create anything. The laws themselves give descriptions of how the universe works. And, you know, the power to create is not within the law itself. It's a description of how the universe works. But even so, as Lincoln said, right, in this quote that I gave, where was it? Here. No, not that one. Oh, there. Right? So the laws themselves, you still have to ask where they came from. You know, if the laws are there, then someone had to create the laws. I think it's a very naive and simplistic statement that really doesn't have any content. And since Stephen Hawking's not around, he can't debate me on that. Yeah. Anything else? Yes.
You sort of made a distinction which I thought was interesting between, you know, the Big Bang not being an explosion, but sort of the creation of something. And could you maybe say a little bit about that? And what if this blob of 10 to the 60th something just sat there, or what was the impetus?
That's one of the ideas, that the universe was kind of stagnant forever. This idea. It really has problems. The math doesn't let it. A stagnant universe isn't stable, so it can't really sit there forever and start to expand. And so this idea is not very well accepted, but you still find it in the literature. So the Big Bang was actually a term that was coined by a physicist named Fred Hoyle. Fred Hoyle did not believe that the universe had a beginning. He thought that although the universe was expanding, there would be creation of matter as the universe expanded. So it keeps getting bigger, but matter keeps creating in the spaces in between, so it can exist forever. That was shown to be false. But the story goes, and I'm not sure if the story is true, that Fred Hoyle invented the term Big Bang because he thought the term was so preposterous that nobody would accept the theory. And so the reason is because he knew it's not a bang of pre-existing material. So it really is a bad name for this beginning. Lemaitre, who was a priest who actually came up with the idea of a Big Bang before Hubble discovered the expanding universe, called it the primordial atom, or the cosmic egg. And, you know, you come up with a bunch of names. I call it the origin of the universe. That's the best explanation for what the Big Bang is. So does that kind of answer your question? All right, good. Yes?
I think you said that there was some point in time, it was 10 to the minus however many seconds, that theory goes up to.
Right.
But beyond that, theory doesn't tell us about,
right,
and perhaps would never tell us
right,
about. Why that line? What causes that line to be there?
Good question. So that line is about 10 to the minus 32 seconds. So if cosmic inflation is correct, then before that time, the universe expanded so rapidly that anything that happened before that is beyond our sight. So when we look out farther and farther in the universe, we see farther back in time. When I look at Saturn, I see not Saturn as it is now, but Saturn as it was about 2 hours ago. When I look at the nearest star, I see that star as it was about 4.5 years ago. When I look at, distant galaxies, I see them as they were billions of years ago. There comes a point where we can't see any farther because the light hasn't had enough time to get there and never will. And so that is one line that you can't cross. But another line that comes into play is we have a theory of how gravity works. It's called general relativity, Einstein's theory. We have a theory of how the world works at very small distances. It's called quantum mechanics. Both those theories are so well, determined. I mean, they're so experimentally so well verified that we're convinced they're both true, but they're incompatible with each other. Okay, so you have two theories that are true. One that describes gravity at large scales. One that describes the universe at small scales that are incompatible. Well, when you get the universe compressed into a very small size, you have to make those compatible somehow. What physicists say, we have to come up with a quantum theory of gravity, which we don't have. And that is the atheism of the gaps. The hope is that the quantum theory of gravity will somehow solve all these problems and remove the need for God. And so the breakdowns are, if inflation happens, we'll never have any physical evidence of what occurred before 10 to the minus 32 seconds. And we don't have a theory of what occurred then unless we have a quantum theory of gravity. Again, every time we've made a new discovery, it's given more evidence for God. So the atheist who's putting all their hope in the quantum theory of gravity will remove the need for God. I would put my bets just the opposite. If and when we ever develop a quantum theory of gravity, it will not. It will do just what everything else has done, give more evidence for a true beginning of the universe. Yes?
Could you define again the entropy problem?
Yes. So the entropy problem is the fact that if you take the universe back to its earliest moments, it's highly ordered, and it's become more disordered as time goes on. This is using entropy very colloquially, but how we tend to think of it. And so the Big Bang, again, is a misnomer. It wasn't some explosion that created a disordered universe. It's a highly ordered beginning. So even though it might look like things are getting more ordered, it actually turns out that the most ordered state of the universe is right at its beginnings, which is hardly a chaotic explosion. And it's so highly ordered that, Penrose gives it this, calculation of 1 part in 10 to the 10th, wherever I had that. I don't remember. 1 part in 10 to the 10th to the 123rd is finely tuned. So he calculates the probability of getting an entropy as low as it is, and he comes up with this highly improbable number. Okay? So again, this is why the Big Bang, it sounds like this non-theistic, chaotic explosion, but everything about the Big Bang points to a theistic ordered, creative event. Yes?
You might as well just mention the fact that eventually all stars will die, and there will be no energy. So there will be no source of energy for life as we know it here on our planet. So in that sense, entropy, how can you argue that there's an infinite past time?
Yeah.
If that was true, then all the stars would be extinguished today. So entropy in itself is a very good argument for a finite past time.
There's a lot of arguments for the universe being finite and fine-tuned, and I'm looking for entropy and I don't remember it, so okay. I know how to find it. Yes?
I've heard there's no stupid questions.
There are no stupid questions.
But I'm going to prove that wrong.
All right.
In quantum physics, could electromagnetism make it impossible to measure gravity?
I don't think so. We measure very precisely both the properties of gravity and the properties of electromagnetism. In fact, we know that there are 4 known forces in the universe: electromagnetism, gravity, what's called the strong force, and the weak force. And they're all very well understood, gravity being the least understood, because gravity is actually very weak compared to the other forces. And so that's a problem. I happen to be right on the right page, even though I wasn't looking for it. So that's a real problem that we don't have an answer to.
Well, and now that gravity has been defined as wave energy, does that in any way affect?
Right. No. In fact, all it does is again show that we really understand gravity. Einstein predicted gravitational waves, and he thought they would be so hard to detect that humans would never be able to detect them. So this is quite remarkable, right? In 1915, 1920, something like that, Einstein said, this is a prediction of my theory, but we'll never detect them. And 100 years later, we see that. It shows how ingenious humans really are. So I think the best we can say is so far, we continue to understand these 4 forces at a deeper and deeper level.
Thank you.
You're welcome. Yeah.
I've heard some things that say that the speed of light is slowing down. Is there any evidence of that?
Yeah, so, no, there's not. The short answer is no, there's not. I can't remember, Norman and Setterman, I think, are the two.
Setterfield.
What's that?
Setterfield.
Setterfield are the two scientists that propose it. So, there are different understandings of the biblical record of creation. There are some Christians who believe the biblical record requires that the earth is only 6,000 to 10,000 years old. And when you make that presupposition, I don't think it's really in the Bible. When you make that presupposition, you then reinterpret everything we all see in light of that. This is really what is done. So I've actually taken the same data that these guys use to say it's slowing down and plotted it using what I think is a more reasonable way to plot things, taking the uncertainties into account, and there's no evidence that it's slowing down at all. They use a lot of fancy words and a lot of words to try to say that it is. But, to me, the evidence from science that supposedly points to a 6,000-year-old Earth or so is kind of like somebody who's already decided Santa Claus exists. And so therefore, the fact that the cookies were eaten in the morning gives evidence that Santa Claus must exist. Right? Once you've made a decision that this is how it is, then everything is reinterpreted in light of that decision. And, there isn't evidence that the speed of light is slowing down, at least not to the degree that's required for a young Earth. But if you've already decided the Earth is a certain years old, then you will understand all the evidence in light of that. I'm going to talk a little bit about this tomorrow night. Yeah.
I have a friend who's a devout Jew, and I invited him to come to these meetings. He said he's not interested. He said his religion, his faith, and he said your faith too, referring to me, is based on belief and in God, and your belief in your relationship to God, and so on. It doesn't really matter beyond that. So, what should I say to him?
Well, I can't tell somebody else what their belief should be based on. I know what my belief has to be based on, right?
And is it belief that Christ died on the cross for you? It's got nothing to do with how the universe was started.
But even that belief is evidentially based, right? I mean, Thomas is the patron saint of all scientists. Thomas said, unless I see the evidence, I will not believe. And Jesus is going to say to him, you idiot, just believe. He said, here's the evidence, now believe. Jesus said the greatest commandment of all is to love the Lord your God with all your strength, soul, heart, and mind. Mind to me means to be able to ask tough questions and think through the evidence. I believe that biblical faith is always evidentially based. And that biblical faith is not just an intellectual belief, it's a trust. And you would be a fool to trust somebody who's not trustworthy. So how do you determine that God is trustworthy? By demonstration of that. And one of those demonstrations is that the statement about his nature and creation in the Bible is consistent with the statement about nature and creation that we see in the creation itself. That, to me, gives evidence that the God who wrote the Bible is trustworthy, because he makes statements about what creation is like in the Bible, and I can test those. In fact, Paul writes in 1 Thessalonians 5 to test everything and hold on to what is good. And so, to me, my faith does ultimately boil down into a belief based on evidence in the resurrection. But I think all of scriptural faith is an appeal to reason, to look at the evidence and believe. I mean, Paul goes, to the Acropolis, and he gives this very evidentially based sermon on why to believe in Christ. He writes in 1 Corinthians 15, if Christ did not rise from the dead, then our faith is in vain. He's appealing to a historical event. And so I think that, to me, to believe something without evidence is not faith, it's stupidity. Christian faith is always based on evidence. And so that's how I would answer it for myself. I think it's very scriptural. And again, ultimately, Christian faith is not just intellectual, it's actions based on trust.
Okay.
Yeah.
If God is at the start of the Big Bang, that created the Big Bang, what is it? Is it a man? Is it the sun of all knowledge? Is it Siri? Is it a computer? Is it a spirit? Is it light? Is it energy? Is it an angel? What is it?
What is God?
Yeah, at the start of the Big Bang. Is it a man?
So, the only way we know God, what God's like, is He's revealed Himself to us.
Right.
And He's revealed Himself to us in three ways.
Okay.
In nature itself,
Yes.
in the Bible, we believe, and in the person of Jesus. So if you want to see what God is like, you look at the Revelation. You know, if you wanted to try to explain yourself to a beetle, you know, a little bug, you couldn't do it without doing something drastic like becoming a bug and explaining yourself to him. The bug can't understand who you are. So God, in order to explain Himself to us, had to give some kind of special revelation. And we believe that special revelation is in the Bible and in Jesus, and it's that where we understand what God is like. And we use English words or language to try to explain it, but it's all unsatisfactory. You cannot explain an incomprehensible God with finite language, but we try to, because it's the best we can do. A really good book on this, that at least illustrates it, is the book Flatland by Edwin Abbott, written in 1884. And in the book Flatland, there's a universe that's two-dimensional, like a piece of paper. It's flat. And a three-dimensional being like you and I, and those people are called flatlanders, a three-dimensional being like you and I, which are called spacelanders, tries to explain themselves to the flatlander, and they can't. In fact, I'll talk about this a little bit, maybe. No, I'll talk about this for sure on Sunday morning when I talk about miracles. So the point is, if a two-dimensional being can't even understand a three-dimensional being,
Right.
then us three-dimensional beings will never fully comprehend a trans-dimensional God. So all we can do is use language to best explain that being in terms that He has used to describe Himself, but we'll never fully comprehend it.
All right.
I can answer his question.
Yeah.
Because I witnessed to a Jewish lady for 3 years, and the only way I caught her attention, and I'd never done it before, but the Holy Spirit showed me how to do it, is to show her Jesus in the Tanakh.
Yeah.
Because she didn't believe that the New Testament was a Jewish book,
Yeah.
which is a lie. But
Right, certainly, I mean, that is the approach to talking to a Jewish person, to show Jesus in their scripture. But that's different than the question about what is faith or belief, I think. But yeah, I agree with you. Jesus, you know,
fulfill prophecy.
we as Christians know that the story from the fall to the new creation is about the redemption of humans through Christ.
And the pre-incarnate
Yeah.
manifestation
Yeah.
of Jesus.
I think we should stop at this point. This guy's been up since 1 o'clock this morning.
But if you have other questions, I'll stick around and talk to you.
How do you self-publish?
You pay a publisher to do it for you. That's how I do it.
So he's graciously agreed to stick around for a few minutes afterwards, but let me close this with a word of prayer. Lord God, thank you so much for your presence with us tonight. Please help us to internalize what we've heard and to draw ever closer to you as a result. Please go with us now as we return to our homes, and we just pray for your blessing on this meeting. In Jesus' name, amen.
Amen.
Let's give Mike another round of applause.